Okay, I'd like to talk about the HP16702A Logic Analyzer, and I have one over here. It's a more advanced Logic Analyzer that has a Windows type of operating system. This one has two cards in it. They're HP16718A cards. One's in the D slot, the other one's in the E slot, and they are 333 megahertz state or 2 gigahertz time Logic Analyzer cards. So we'll take a look at the back of this before I power it up. Okay, so this is the back of the HP16702A Logic Analyzer, and in this one I only have cards. There's room for 5 slots, and I have D and E slot filled with Logic Analyzer cards. One important thing about this Logic Analyzer is I have a PS2 mouse, and there's the mouse, and it has to be just the right type of mouse. Luckily I had a whole bunch of USB mouses and PS2 mouses. I happened to find one that did work with it. I tried different ones. Luckily I had about 100 of them, and going through them I found one that actually worked with it. Not every mouse will work with it, and the thing won't boot up unless you have a mouse. So here's the power cord for it, and so these are the cables I have. So there's 4 pods per card coming out, and today we're only going to use 2 of the pods on card E. Card E is the master card, and so we're going to look at an 8031 microcontroller and try to replicate a program that's in it. Look at the code using a Logic Analyzer. So here's the 8031 microcontroller that we're going to look at, and with pod 1 I have that connected to the address bus, and the address bus is a 16-bit bus, parallel bus, and pod 2 is connected to the data bus, which is an 8-bit data bus. And I also have a wire here for the clock. It's called the J clock, and that's going to be connected to the PSEN signal. That's like whenever the memory is accessed, the external memory is accessed, that toggles. So that's the clock that the system toggles on to be able to read the memory. So this is a mouse, and I put a sticker here that says a label. It says HP16702A to know that this mouse does work with this Logic Analyzer. So one trick with this system is not to connect this clock until the system is powered up, otherwise it jams up the computer. So that was one thing that I found. So I'm going to power up this Logic Analyzer now, and you can see how it powers up. So I'm going to hit the on switch. And this is a little bit different than other Logic Analyzers I used in the past, in that it uses some type of Windows operating system. The other Logic Analyzers seem to have their own operating system custom to that Logic Analyzer, but this one seems like it's like a Windows 95 or 98 type of system, and it does take quite a bit of time for it to come up. So it says it's from maybe 1998. It is powering up now, and it doesn't have the touch screen. The other Logic Analyzers I had before, this was always a touch screen with the HP Logic Analyzers, previous models. Now it does use a mouse, so it is somewhat different, and some things are the same as some of the older Logic Analyzers. Now one thing I would recommend, yes, always get the latest and greatest Logic Analyzer you can. Logic Analyzers are somewhat obsolete now these days, but if you do get one, maybe get one really old one if you do a lot of retro stuff, and then maybe one new one, because everything is so much faster now than what it was back in the day, that the older types, you couldn't use. But the bad thing about the new ones is they're very sensitive to operating systems and failures. Things, they tend to fail. They're not as reliable as the old ones. So that's the risk you have. I'm sure when this was new, it had a lot of other options, software, things that would come with it that would make it a lot easier to use. But these days, being the processors that probably like the processors now that you would use on this are newer than what the Logic Analyzer was. A lot of things weren't developed for it. So anyway, you could see this Windows type of operating system come up. Looks something like Windows XP, and so it is starting up a session. So when that starts up, we'll set it up for this 8031 system. So this big screen comes up. It does take some time to load this logic analysis system, Allergent. And so I got this used off of eBay. They're very cheap now because nobody wants these things. They're heavy. It's good for hobbyists like me if you're into computers and software engineering and computer design or designing FPGAs. It is very nice to have some of them, but you don't want to buy too many of them. They take up a lot of space, and there's smaller things you could get out there now, but they're kind of neat to work on though. It's kind of like the last resort if you have to troubleshoot a computer system if the debuggers don't work and the support software you get doesn't work. This is the way to go. So this Logic Analyzer seems to have a lot of errors. Things aren't working in it, but it still seems to work for what I'm using it for. So I do get a bunch of errors, but I just ignore them. And maybe one day I'll go in and try to clean up the cards and try to figure out what these errors are about. So I'm just going to clear this message, and oops, I keep thinking it's a touchscreen because the other Logic Analyzers I had that. So I'm going to clear it. I'm using the mouse here and hit close. So we're going to set this up now. So now that I have the Logic Analyzer powered up, I'm going to hook up the strobe. So luckily I have these header pins here. That's a big problem with if you have a Logic Analyzer. Usually they don't have the pins to connect it. So I'm going to show you how I talk to this 8031 system, and I'm going to try to zoom into this to my computer here. So I have this I'm using TerraTerm, and this is what I call a monitor program that I use to talk to the 8031. So if I push an N command, that gives me a menu. So what I have in here, there's a little program that we're going to try to back out using a Logic Analyzer. So this is a way you could kind of reverse engineer software out of a microprocessor if you don't have the code. So what this program does, what I'm going to show you first, this is the internal scratch pad RAM. When I hit this D command, and over here between addresses 30 and 7F here, I want to initialize the data. Right now it's all random kind of data, so I have a little program in assembly language. I'm going to look at that again. That'll zero out or initialize that memory. So the way to run a program on this device is to hit the J. So I hit a J, so the program ran very fast. So now if I look at it, it's all zeros. So we're going to look at the code that wrote all zeros from RAM positions and total static RAM positions 30 to 7F. So it's assembly language code. So I do have the listing, but we'll try to look at it using the Logic Analyzer first, and then compare it against the code to see if it matches. So now we're going to set up the Logic Analyzer to read this card, one manually. I'm pretty sure you could store a lot of programs inside of it and save your setups, but I don't have that right now. So what I'm going to do, I'm going to go through step by step and show you the setup. It doesn't take too long to do. So the first thing to do is hit the select, and so we want to do the setup here, setup and trigger. So we're using Analyzer E, This timing zoom I'm not really using. I just want to turn that off because I know that was it had some errors in it, but so we don't really need to get too much memory. It has like 8 meg, so we'll just use 8K. And our sample period, this is a slow processor, so maybe we'll use like 100 here, 100 nanoseconds. We don't need 3, so we'll pick 100 nanoseconds there, and we want to do state mode rather than timing mode. Okay, yeah, I guess I didn't need to change that the 3 to 100. So, but likewise, yeah, we have the 8K acquisition depth. So trigger position center is fine. Yeah, I want to hit this advanced clocking. So we want to clock when the J clock goes up. So there's an arrow here, which is nice when it has a double end on it. It means there's some activity there, and that's good to see. So the next thing to do is go to this format page, and I'm going to enlarge this, maximize this. So when you see all these arrows here, that's a good sign. That means there's activity. So if I put a command in, you could see some of these arrows change, and you saw a little change there. And that's good. That means that we're hooked up. If these arrows go away, it means that maybe my system isn't powered on. So anyway, we're going to make an address bus and a data bus. So pod 1 has the address bus. So we're going to just change this to AB. So I'm going to type AB. I'm using the keyboard on the analyzer, and we want to insert data bus. So we're going to call that DB. So I'm typing DB in, and I'm going to hit apply and hit OK. So our data bus, we want the first 8 bits. The last 16, it's only an 8-bit processor, so the last 8 bits aren't connected. And this is our J clock, so you have to have at least 1 clock. So that looks good there. So I'm going to let this run just a little bit now, without setting up a trigger or anything like that. So you hit this to run single, and so I hit that, and of course I get a bunch of errors. It says like run the self-test, and I get a lot of errors, but I'm just going to ignore these errors. I'm going to hit clear message and close for now. I think for the things I'm doing, it doesn't really it doesn't matter. These errors don't impact it. So the next thing I'm going to do is I'm going to select listing. I want to see the listing here. So I do. So I'm going to come down here, and I notice in my listing I'm not quite getting what I want to see here. So there's one other thing I have to do here. I'm going to go back to the setup again, and just wanted to see my sampling. Okay, that's good. Okay, so format. So one thing I got to do here is I got to change this. I'm going to use a user-defined threshold, because I believe this was set up maybe for a 3.2 volt system, but this is this 8031 microcontroller is running at 5 volts. So I want to set my threshold to 4 volts. So I'm going to do that, and okay, so I got the 4s there rather than using TTL. So we'll try running that again. Run single, and I get these errors again, but so I'm going to look at the listing. Okay, so that looks pretty good there. So what I have here is great. Yes, I want to look at this time. It gives me the time. I'm just going to look at it relative, because I notice 544 nanoseconds is kind of like the cycle time on this processor. So what this processor has, this is the address bus, and this is the data bus. I guess we have time in between. So there's a little polling routine in there at this location at 794, It's a loop, 794, 795, then goes 792, 793, 794, 795. So it repeats itself. It's just a little polling loop that's looking for that character. So that's the instructions there and the instruction memory, and that's the address. So anyway, that's the code for this little program, and surprisingly all real computers work this way, and most of it's hidden in our world when we use computers, but in the real world the computers only know this. They know an address and an instruction. Now the newer computers, you know, this is only an 8-bit computer, but the newer computers go up to 64-bit, maybe 128 bits now these days. So this older computer is only 8 bits, but it all kind of works the same way. Computer technology really hasn't changed since the 1970s. At least the idea behind it hasn't changed. The way the addressing modes and the instructions haven't changed. Maybe the bit size and speed has changed a lot, but the way branching works and things like that haven't changed much. So what we want to do now is we have a program that is located at address 800. So we want to capture that code and look at it and compare it against our listing. So what we have to do here is set a trigger to trigger off of address 800. So we go to trigger, and what I want to do, this analyzer has a lot of options, so I want to just store nothing into this pattern occurs, and I want to do it one time. So this is the address bus, so I want to set this to let's see, I want to set it to 800. So I go 0800 and just want to trigger and fill memory. So that's all I want to do. So let's go back to format here, and I'm going to run this, and of course I get these errors. So it's waiting for this trigger. It's waiting for this trigger right now, and maybe we'll look at listing here. And I think if I hit this, if I hit the J command, it'll set the trigger. So there it goes. Yeah, I'm getting a couple of things I wouldn't expect to get. So let me try this again. Yeah, so the one thing I have to do here is I gotta make sure this replaces hit. And then I think it was mixing data with that I had previously. So 0800 and store nothing into pattern occurs. Okay, so I can look at the listing here, and I get these error messages, but it's waiting for the trigger. So I'm going to hit the J command. Okay, yeah, I got exactly what I wanted here. Okay, so I'm going to close this, and I'm going to scroll up here a little bit, and this is the code. And so what I'm going to do is I'm going to take a few photos of this, and then we'll go back and we'll compare it against the assembly listing to see if it matches. Okay, so let's see what else we could do with this logic analyzer. Just wanted to randomly look at some of these tabs here, and it looks like this one is it's pretty good. It has a lot of stuff in it. So you could being that it stores so much, you can go and look at try to capture kind of unique things. Usually you could trigger off of a whole bunch of different things. So let's see, just seeing what else we have in here, if there's anything else. So I guess the waveform is kind of neat to look at. So I know these do have disassemblers in them where you can see the code. So, but we're going to do this manually. So it looks like, yeah, it looks like I got the first instruction here. So I'm going to see how intuitive this is. I know. Let's see if I change this to 1,000 nanoseconds. Does it give me more data? Okay, yes. So that's pretty neat. Yes. So you can. It is giving you. It's giving it to you like in a different form though. I wonder what that 00 is in there. That's kind of strange. But we're but it does, so you could set up like different markers and do searches, comments, analysis, mixed signal. So this is the waveform display. So let's see if we can get, yeah, maybe 10 microseconds. See what that looks like. Okay. So that's interesting. So it looks like you could get it in, you know, kind of a, we'll look at 1 microsecond again. But it looks like you could get it in, yeah, it gives you the address and the data bus, and you could get it in this, you know, hexadecimal form. So I wonder what else, if you, okay, so you can do an expand. Okay, so that's the way I'm kind of used to looking at it. And let's see, I wonder if there's a way to shrink this down, but I guess not. So you kind of have to scroll through this, and you can see like this is our where 800 was, but you can look at it in a binary form. And so there's the address and the data bus. Okay, you could expand it. So yeah, that's kind of interesting there. So it is pretty intuitive in that, you know, you learn how to use this by trying different things on it. So that's interesting there. So anyway, we're going to go and compare this against the code to see how well we did, and take a look at that soon. So one thing I wanted to show you is turning off this logic analyzer, because you can't turn it off like the other older previous logic analyzers. You just turn off the power switch, but this one you have to do a nice shutdown, otherwise you ruin the operating system. So normally what I'll do is I'll maybe close these windows. So we'll close these windows little by little. So we'll hit close, and so we got system. So I think we could hit exit here. So all changes will be lost. So that's kind of closing the session. So there's a session manager. So what you want to do is hit the shutdown. So I'm going to back up here a little bit just to show you what happens. So you want to do a nice general shutdown on this. So I hit shutdown, I click on that, and I hit power down. So you get a message that it's okay to turn off power. So this is blinking now, which means it's okay to turn off power. You don't want to turn it off when it's not blinking, otherwise you could corrupt the operating system in it. So we'll turn that off, do a nice gentle shutdown. So anyway, we'll go and compare the what we got out of this analysis to the assembly language listing next. Okay, so I'm going to compare the assembly language listing against what I got on the HP16702A Logic Analyzer. So the first address here at 800, I get a 79. So I got the 79 there, so that looks good. So at address 801, I get the 30. So there's the 30. At address 802, I get 74. So that checks. At address 803, I get 00. So that checks. At address 804, I get F7. So I see F7 there. At address 805, I get a B9. So there's the B9. Now I get this extra thing at 802. There shouldn't really be 802. It should go to probably should go to 805. This should really be 806, but maybe because of the extra, it's a 2-cycle instruction, it's kind of left over from before. That's a possibility. But over here I do get an 806. I get the 7F there, and 807 I get the 02 over there. So 808 I get an 80. But here, this instruction, it should jump to this label, 80A, and I don't see it jumping. I do see 80B. It goes to 80B here. So kind of missed the instruction. So maybe this logic analyzer is too fast for that processor. Its processor has like less than a megahertz frame rate, where this logic analyzer is good for 333 megahertz. So it's just such an accurate analyzer. Maybe if I change some of the settings on it, I would get closer. I'll have to work on that. But anyway, I did do this also with some older logic analyzers, and I did get closer to what I would expect. But anyway, for every address, I do see the instruction, but I don't see the sequence. So anyway, hope you enjoyed this video. So this is an example of using the HP16702A Logic Analyzer. Bye now.